Of rational functions today. We're going to be looking at algebraic structure of rational functions, and I'm going to do some old school stuff with you, stuff that you guys know from like fourth grade, adding fractions, all of that kind of stuff. But what I'm really trying to do is not necessarily get you guys to be able to add fractions. I mean, you learned that way back when, but I want you to remember the steps because those are the exact same steps we're going to be using when we're dealing with these weirder things, especially with polynomials. So let's get this party started, shall we? Come on, Microsoft Paint. Figure out what you want. Oh, no, don't do that. Over here, scroll down. Come on, dude. Work with me here, buddy. There we go. All right, there we go. Come on, figure it out. There we go. Pull it down. All right, there we go. Adding fractions. 5 over 4 plus 3 over 4. You guys remember how to do that, right? Since there's the same denominator, then we can kind of consider that as 5 plus 3 over 4. And then that's really just 8 over 4. I can divide the top and bottom by 2, and I end up getting the number 2. Or I'm sorry, I can divide both the top and bottom by 4. You guys remember this game, right? Alright, similarly, let's do this one. Let's do this one. Similarly, 7 over 6 minus 5 over 6, that's simply, you know what, I'm just going to do the 7 minus 5, which is 2 over 6. I keep the same denominator, but then I change, I subtract or add whatever the numerators, and then you end up getting 1/3, if you were to reduce that fraction. For this one over here, what I'm going to need to do is I need to make a common denominator. In order to do that, I would choose 40, I'm thinking. So in order to make this denominator 40, I need to multiply the top and the bottom by the same number. So I'm going to multiply it by 8 over 8. Because really what I'm doing there is I'm multiplying it by 1, which isn't changing the number whatsoever. And then over here, I'm not going to multiply it by 8 over 8, I'm going to multiply it by 5 over 5. Because that will make the bottom 40 over here, and that will make the bottom 40 over here. So that's equal to negative 4 times 8, I'm sorry, I'm not very good at this stuff in my head, 32, that's negative 32 over 40 plus 35 over 40. This is also known as, I can now add the tops because the bottoms are the same, so it's going to be over 40, guaranteed, I know that, but this is going to be 3. You guys remember how to do this? Is vaguely familiar? Alright, the only thing I'm going to say about this thing is you pretty much follow the same things, but when you subtract a negative number, you need to think of it as adding a number. You can change those signs, so make sure you're very, very careful with that. Alright, let's take a look at this one. 2, that is not a fraction. Actually, it is. It's the same thing as 2 over 1 plus 13 over 4. And I'll tell you what, I'm not even going to go step by step through it. I'm just going to say that's equal to, let's see, I guess I will go step by step through it since I got to do it in my head. That's 8 over 4, and so that's 13. So 19 over 4. If I got that wrong, I apologize. Let's talk about this one. Now, what I could do is I could say, alright, 5 times 2 over 4 times 3. I don't need to worry about common denominators in this case because I'm multiplying. However, when I multiply 4 times 3, I can make this as, 5 times 2 is 10 over 4 times 3 is 12. I can reduce that to 5 over 6 by dividing both top and bottom by 2. The only thing I want to show you before I get into this is this. The 5 over 4, I can actually do my reducing first before I do my multiplication and get straight to this answer. I'm going to do it a little bit slower, and it's going to look like it's harder, but it's not. 5 over 4 is 5 divided by 2 times 2. I got the times 2 from the 2/3, and I got the divide by 3, which basically multiply all the tops together and multiply all the bottoms together. But before I multiply, this 2 right here will cancel out with that 2 right there. It doesn't actually matter. You can actually cancel the first 2, but I mean, just one of the 2's on top cancel out with one of the 2's on the bottom. And you end up with 5 divided by 6. By the way, when you cancel them out, this doesn't change to a 0, it changes to a 1. If it changes to a 0, then everything would end up being 0, right? So, anyway. When you're dividing a fraction, let's figure out how to deal with that. First I'm going to ask you, what is 9 divided by 3? Well, 9 divided by 3 is the same as 9 times 1/3. I guess maybe 9 divided by 3 is the same as 9 times 1/3, right? Because the 3 is supposed to go in the denominator. So what I can do is I can change a division symbol into a multiplication symbol if I take the second fraction and I flip it over. By flipping it over, the mathematical term for that is reciprocating. So this would simply be 1/5 times 4/7. I would play that game that I did here about reducing this thing, but none of it can be reduced. These are actually kind of, these two bottom ones are prime, so I know that even if I broke the 4 up into 2 times 2, it won't have any. So then, let's see, that would be 4/35. Alright, this one over here, let's see, the 1/9 times -3/4. Sorry. Alright. Let's see. I'm actually going to reduce this a little bit. I'm going to divide both the top and bottom by 3, and so this becomes a 1. And this becomes 9 divided by 3 is 3. So that's equal to -1/12. By the way, that negative can go in the numerator. It can also go in the denominator. It can also go in front. And to be honest with you, I think the in front version is the most used version, but technically, mathematically speaking, all of them are correct. Essentially, I want you guys to know these steps. Know the steps on how to add, subtract, multiply, and divide fractions, because that's going to be key to what you're going to be doing in the coming